Welcome to This Explainer. Today, we're tackling a massive topic, managing tail risks. Specifically, we're diving into the really rigorous demands of nuclear safety and emergency management, and exactly how the SASB standard approaches preventing catastrophic accidents and maintaining a strong safety culture at nuclear power plants.
So how do you actually measure a disaster that hasn't happened yet, right? That is the core paradox of managing a tail risk. Now, a tail risk is highly improbable and might literally never happen in our lifetimes, but if it does, the consequences are absolutely catastrophic. And because you can't just look at a high frequency of past errors to predict the future here, managing it requires a really rigorous, structured, and proactive approach. To unpack all of this, we're going to follow a logical flow. We'll start with the nature of tail risks, move into measuring nuclear safety, map out the anatomy of an event sequence, and finally, look at building a safety culture. Let's jump right into Section 1, the nature of tail risks and understanding this high-stakes environment. Decades can go by without a major public safety incident, but here's the catch. A single, infrequent accident anywhere in the world instantly sends shockwaves through the entire global industry. The human and environmental stakes are just so incredibly severe that the margin for error isn't just small, it is effectively zero. And a failure in nuclear safety, it isn't just a bad fiscal quarter, it's a true existential threat. Beyond the tragic human impacts, we're talking about the immediate loss of a license to operate. The staggering financial liabilities and cleanup costs can literally make the continued operation of a plant completely uneconomical overnight. These entities are facing massive company-ending repercussions. Moving along to Section 2, measuring nuclear safety, let's look at the hardware and quantitative metrics. When we look at the official SASB standard, it demands that energy providers report on two very specific metrics for nuclear safety and emergency management. One is purely quantitative, counting the actual units, and the other requires some pretty deep discussion and qualitative analysis. So, SASB basically demands both hard, objective data and qualitative proof. You have the hardware on one side, the physical units and the audits that verify their safety, and then you have the software on the other, the safety culture and emergency preparedness. True resilience is practically impossible unless both sides of the scale are working in perfect harmony. To track that quantitative side, the standard relies on a really precise definition of a nuclear power unit. And it's not just the glowing reactor core, right? It encompasses the entire interconnected ecosystem of equipment, structures, and systems required to generate electric power without posing any undue risk to public health and safety. But simply counting these units? Not enough. The standard requires them to be broken down by the results of their most recent independent safety reviews. And independent is absolutely the key word here. These reviews have to be conducted by third parties who have zero direct involvement in the plant's design or its day-to-day operation. That ensures a completely unbiased, uncompromised evaluation. This brings us to Section 3, Anatomy of an Event Sequence. Let's look at how accidents actually happen. Because a disaster of this magnitude doesn't just happen spontaneously all at once. It always begins with what the industry calls an initiating event. Now, this can be a natural disaster, like an extreme weather event or an earthquake, or it can be a human-induced error. Think of it as the very first domino to fall. That initiating event triggers a highly dangerous chain reaction. Step 2 is system failure. Components basically stop working the way they were designed to, which is often compounded by the action or sometimes inaction of the operating staff. If this chain isn't broken right then and there, it leads directly to Step 3, which is the potential exposure of individuals to radiation. To break this dangerous chain, to stop those dominoes from falling in the first place, the SASB standard expects entities to detail their rigorous management systems. This means having concrete proof of staff training, strict enforcement of rules, the deployment of advanced technology, and highly rehearsed emergency plans. It's really all about having systems in place to avoid, detect, and respond to those initiating events way before they can escalate. Finally, Section 4, Building a Safety Culture, the ultimate human failsafe. The stark reality of complex engineering is that technology can and eventually will fail. And because hardware and systems can fail, the qualitative metric in the SASB standard demands robust evidence of a positive safety culture. It's actually the human culture that prevents component failures from cascading into a catastrophic event sequence. The standard explicitly looks for 9 specific traits within an organization. It's not just about letting some dusty safety manual sit on a shelf. We're talking about personal accountability,
It's fostering an environment where any employee can raise a red flag without fear of retaliation and maintaining a constant questioning attitude, never just assuming something is safe today because it was safe yesterday. These traits ensure that the staff is actively empowered to act as that ultimate fail-safe.
And entities don't have to invent this culture from scratch, thankfully. They can demonstrate their commitment by implementing established, globally recognized industry frameworks. This includes the principles from INPO, the Institute of Nuclear Power Operations, and the best practices set out by the IAEA, the International Atomic Energy Agency. Aligning with these bodies proves they have a serious, systemic approach to safety culture.
To leave you with a final thought on this explainer, effectively managing tail risks means accepting that true resilience is never an accident. Meeting the really rigorous demands of nuclear safety and emergency management requires objective structural reviews, perfectly paired with an uncompromising, accountable human culture. So, are the organizations powering our grid merely checking compliance boxes, or are they deliberately cultivating the kind of questioning culture that stops a disaster before it even begins? That is the ultimate question for investors, regulators, and really all of us relying on the grid.